All right, number 13. First thing I'm going to do is label the currents. Start at the battery. Current coming out of the battery, let's call this I. So then current I comes up like this, and then in like this to this junction. And then right here, current I splits. Now, this problem wants us to find the current in the 12 ohm resistor down here. So I'm not even going to label the currents going up this way, right? Because we're not concerned with up there. So let's just label the currents that come down towards the 12 ohm resistor. So we'll call this I1, and then we'll call this I2. Oh, you know what? Before I started recording, I labeled these differently, huh? Is that going to mess you up? That's I2. We'll say that this is I3. And then the current here would be I1, right? It's the current before splitting right there. Okay, so then over here, we're back to I. Okay? Now, the key to circuit problems is to draw simplified pictures. So I'm going to need a lot of room to do this. So I'm going to shrink this guy down. In fact, here I'm going to get rid of the question to make even more room. So we're finding the current in the 12 ohm. We know that. So let's take this picture here and shrink it down. All right, so to do our simplification, we're going to start with the 2 6s and the 4 and the 12, because those guys are in parallel. The reason they're in parallel is the circuit splits right there and right there. So we're going to start with the 6, simplifying the 2 6s, and then the 4 and the 12. So you got to redraw the whole diagram. So redrawing the diagram, here's what I'm going to do. I'm going to draw it big and then shrink it. So we got the 3 ohm, and then it goes up like this. Like that. Like that. So here's our 3 right here. Okay, a 6 and a 6 in parallel, that simplifies to a 3. And then a 4 and a 12 in parallel, that simplifies to a 3 as well. And then this guy right here is 2. Okay. So that's 18 volts. Label our currents. This is I. This is I. Okay, what current goes down through here? This is I1. I1. And then here we're back to I. Okay? So now, what are we going to simplify next? The thing that we're going to simplify next, these two the 3s are in series, the 3 and the 2 are in series. So let's draw it out. So I'm going to shrink this down. So that's our next simplified. Okay, so the next picture looks like this. Volt, that's a 3 ohm. 3 ohm. 2 3s in series, you add them up in series, that's a 6. A 3 and a 2, that's a 5. Label the currents. This is I, and then the current going down here is I1. And then over here, we're back to I. Okay? So we'll shrink this down. So any questions at all? Okay, next thing we simplify. We're going to simplify the 6 and the 5. They are in parallel. So when you simplify that down, it's 2.73. So let's see, I'll come down here. So the next picture is going to look like this. 3 ohm, a 6 and a 5 simplified is 2.73, and then 18 volts. The current flowing through here is I. And remember, current in series is always the same. Okay. So let's see. Why don't we put it over here? No, we'll stick it here. There. And then the final picture is going to be 5.73 with current I. Now, once you've simplified it all the way down, you start working your way back to the beginning, figuring stuff out as you go. It's like a puzzle, dude. It's like a puzzle. So we're going to start with this most simplified picture, the one we ended with. This is the nicest of all situations because why? We got one battery and one resistor. So the voltage of the battery must be the voltage across the resistor. Because look, if that's an 18 volt battery, that means 18 volt and 0 volt, right? So how many volts do we have right there? 18. How many volts do we have right here? 0. So how many volts are across that resistor? 18 volts. So, right? So we do Ohm's law. Ohm's law is delta V over R. So you take 18 divided by 5.73 and you get 3.14 amps. Right? So guys, I'm going to be using this equation a bunch. I is equal to delta V over R. That's just Ohm's law rearranged. Okay? So that's how I got the 3.14. 18 over 5.73. Okay, so the current over here must be 3.14 amps. The current right here, 3.14 amps. Current in series is the same. Okay? Up here, what's this current? In fact, let me make this picture a little bigger. Let's expand this slightly. All right, so in this picture here, this current right here, this I, is 3.14 amps. The current coming out of the battery, I equals 3.14 amps. Right here, 3.14 amps. Okay, so ultimately we're trying to find the current in this 12 ohm resistor. So let's now figure out what I1 is. So I1 is the current that comes down after current I splits. Okay, so how do we find that I1? Well, here's what I would do. Come to this guy right here. Who is this dude right here, this 2.73? Who is that resistor? The 2.73, it's these guys, right? So I'm going to find the voltage across the 2.73. The voltage across the 2.73, you go delta V equals IR. You get 8.58 volts. Okay? If the voltage across this guy is 8.58 volts, the voltage across this guy must be 8.58, and the voltage across this guy must be 8.58. Let me explain, because I don't think you guys totally get this yet. Look, here's how volts work. Start at the battery. 18 volts, 0 volts. So how many volts do we have right here? 18 volts. How many volts do we have over here? 0. Right there, 0. Now look, what happens when you cross this first resistor? You're going to lose some volts, right? How many volts do you lose across the first resistor? Just go I times R. 3.14 times 3, we get 9.42. So the voltage across this guy, is 9.42 volts, which is a loss. So 18 minus 9.42 brings us to 8.58. So this point right here is 8.58 volts, right? We lost 9.42 volts. We're at 8.58. All right. Notice what happens across the next resistor. How many volts do we lose across this next resistor? 8.58, which is perfect because why? We need to be back to what? To 0. You got to be back to 0 because that's what we said the negative terminal was. Okay, so look, come up here to this diagram. How many volts do we have at this point? 18. How many volts do we have at this point? It's the same thing as down here. This is 8.58 volts. Okay, how many volts over here? 0. How many volts right there? 0. So look, notice if you cross this 5 ohm resistor here, how many volts are you losing? You're going from 8.58 over to 0. How many volts do we lose across the 5 ohm? 8.58. How many volts do we lose across the 6 ohm? 8.58. Voltage in parallel is always the same. Okay, so here's what I'm going to do. I need some room here, so I'm going to erase this stuff down here. Oh man, darn it, I'm almost out of time. Okay, so quickly. So I'm going to find I1. Here's how you find I1. I1, you go delta V over R. The voltage there is 8.58 volts. The resistance is 5. So we figured out that I1 is 1.72 amps. Now, what happens to I1? Look at what happens to I1 over here. It splits again. So here's what you got to do, dudes. I know I'm going fast. Find the voltage across that guy, right? We now know I1. I1 times 3, so that's 1.72 times 3. So the voltage across this resistor is 5.16 volts. So look, if the voltage across this guy is 5.16, what must be the voltage across these guys? 5.16. So now you can go I2, which is what we're looking for, is delta V over R. 5.16 divided by 12. So I2 is 0.43, which is the answer. Look, hey, with like the 10 seconds I have left, look, I did the exact same thing here. Who is this 3 ohm resistor here? Who is this guy? It's these guys right here. So if you can find the voltage across this guy, then you found the voltage across these guys.